So those of you who already tried to launch Magma, please delete your network services, as it probably won't work because we need to go through a process here. And sorry about if there was any confusion. This is the first time we're trying to go through a single story throughout the week. So and it is a new network service that we are launching as a team in open source MANO. So it's challenging already. And so sorry about any logistics miscoordination. So in this session, we will start building the network service. So this is the final picture, which shows the packet core along with the emulator of Inode B and user equipment that will go through the physical switches that will emulate the RAN, the access network, and will eventually go through there. First, they will go virtual, just a direct connection, virtual connection. Then this will go to a VNF, which is a router which is outside your tenants. And there you will be able to, from the user equipment, go to internet with just a simple automation scripts, okay? But now we are building all of these. So first of all, we will build these blocks here in blue. This evolved packet core network service, which will eventually be part of a bigger network slice, okay? So this network service is built from one single VNF, as you can see in light blue. And this single VNF is built from two virtual machines. One is the virtual evolved packet core, Magma Access Gateway, and the other one is the generic Inode B plus UE emulator, which is implemented with a software, open source software, called SRS LTE. Okay, so two VMs with different requirements, different software, different providers, different open source projects, but they are bundled in a single VNF. And this VNF is the only VNF of the network service right now. In the future, tomorrow, we will put in this network service another VNF, which is actually a reference to a physical network function. Because obviously, we are not instantiating anything physical. We are just communicating to it because it already exists. Okay, so our network service, it's comprised of a VNF, just a VNF. This is the name of the VNF. It has some interfaces, we can say, in the NFV terminologies, that there are connection points, like the ports that this VNF exposes. We are having to have two management ports, and sorry, this is wrong in the diagram. I'll need to correct it eventually. But just the packet core is connected to the SGI network. We'll update the PDF, okay? Sorry. Just the packet core, as you can see here, is connected to the SGI interface. The emulator is connected just to the packet core. Okay. So we are exposing three connection points. Then we have the VNF itself. This is the diagram of the VNF. And we can see these are the three connection points we are exposing to a network service. Management of each VDU, so that OSM can communicate with it and run commands over it. And we have also the external connection point of the SGI, which is actually the one that will take us out to internet, our users here. And these VDUs have different requirements. They have different images, of course, image names, and different flavors, CPU, RAM, disk. You can see we're putting more resources to the emulator, actually, instead of the packet core, because the emulator runs a lot of software in parallel, and desktop and browser and VNC for accessing and many things that the packet core machine doesn't need. Then we have three interfaces that correspond to the connection points. in the packet core and 2 interfaces in the SRS LTE emulator. And one of these interfaces is an internal VLD. So there are internal connection points. What is an internal VLD and what are internal connection points? These represent or model a connection between 2 elements of a single VNF inside a VNF. And why that is relevant? Because those interconnections are under the control and under the modeling of the VNF provider or VNF vendor. While in the network service, this refers to the infrastructure of the operator. Okay, so VNF vendors can expose certain connection points to the infrastructure and need to adapt to those networks that the operator has in their cloud. But they have control over certain other networks that are modeled under the VNF requirements. So these, for example, can be networks that have fixed IP addressing and they are not routable, for example, and this is the case actually, to show you how it applies in the real world. These 2 ports have fixed IP address, and you can say, but what if my infrastructure is also already using that block? No problem, because this block is not being routed anywhere. It's just internal for the VNF. Okay, so that's the kind of control that VNF vendors have if they are modeling their VNFs and with internal connection points and VLDs. But in OpenStack, this looks just like a regular network. It's just that it's under the control of the VNF provider. That's a very important concept that you should understand. And these VMs are called VDUs in NFV terminology, virtual deployment units. Okay, so we have 2 ways of building this multi-VDU VNF package from scratch. We can use the Graphical Composer, which is a tool embedded in the dashboard to create a package, but it's not covering all the things that we can do. I mean, it's handy because we can see things in a graphical way, but it's slower than what you can do, of course, in scripts or in commands. So this is the approach we are taking. We are building our VNF package from CLI. So everybody should access the machine, OSM machine, and use a OSM package create command using this directory, please, magma. I mean, this symbol here, or put just home OSM Hackfest and your home directory /magma to have everything in a predictable directory of your user. We are specifying the image, the CPU, and memory and storage for the first VDU. We are putting 2 interfaces. This I know I said 3, but these interfaces parameter refers to the additional interfaces that we want besides the first one, which is always management. Optional vendor, and we are saying that it's a VNF package, and we are saying that it's called in this way. So we can just copy this exactly as it looks here. And what we are trying to reach is what is specified in this directory, which is a shared directory in the machine. Okay, so we have 2 options to get in there. First option, to check the other, if you have experience in OSM, a lot of experience actually, and you already built VNFDs and like to have your own VNFD built by yourself and taking control of each section with you if you are already familiar with them, then the best thing you can do is just refer to the final YAML that we are trying to reach and check what things are missing. But for most of you, actually for everybody, because of time and because of this is not a typing contest, I recommend you to just copy the final YAML using this command here. Okay, so I'm user 52. And first command that is relevant for us is the OSM package create command. So I will just copy and paste it as it is there. And that creates a structure under, well, I have more things there. I'm just going to delete everything here just for you to know it should look like. So I'm creating the package again. I create a lot of things. And you will see that there is a Hackfest Magma folder there, and it has the structure. These are empty folders, but the YAML is already populated. You will see here, this is a YAML with comments so that you understand what each section is all about. So if you have experience with OSM, you can easily identify the section you want to modify and do it. If not, or in this case, if we want to get the most out of everybody's time, let's copy the final results. And then this file is different now, right? And what you will take out of this session is what we are doing with this file, of course. This is the important part. So what are we building with that descriptor? We are trying to describe our two VDUs that build out a VNF. So one is the Magma Access Gateway, and the other one is the SRS LTE emulator. Okay. We are creating the interfaces in the first VDU, Magma Access Gateway VDU. We are putting three interfaces. One of them is internal, the other two are external. And for every internal interface, as I mentioned, there needs to be an internal connection point. Okay, so just straightforward, three interfaces. We can control the position, the order of the interfaces in the actual virtual machine we're instantiating. And we are putting a name on the connection points. We are also telling that this management interface of the VNF is set to be the access gateway's management interface. We are giving it a Cloud-init file name because we want to set some things which is called Day-0. We want to set some routing instructions to our access gateway, which we will do later. We are adding a second VDU, which is the SRS LTE emulator, with a specific flavor, CPUs, memory and storage, image, a specific Cloud-init file, which we will populate later. We are putting there two interfaces because it just needs one management interface and the other one is going to the access gateway. So in that case, we are putting the management interface to be a management interface true because, and this is important, there are two ways to configure a VNF. One is a VNF level configuration, and the other one is a VDU level configuration. The VNF level configuration is mapped to a port that you specify in the management interface of the global at the global level of the VNF descriptor, which is tied to our access gateway. And the VDU level configuration is explicitly going to the interface that you set as management interface true. You will understand more on this tomorrow in the automation section. Okay, I repeated already what you didn't see in the slides. And finally, well, I was telling that we are setting the internal VLD to have some specific IP parameters, which will look like a regular network in OpenStack, but we are forcing some IP addressing and network. This is common today in some VNFs that have specific needs, but this has to happen in the internal connection points, in internal VLDs, because the external VLDs are in control of the operator, not of the VNF provider. So if we are building our VNF, we should, and we have specific things in the addressing, in the MAC addressing as well, things like that belong to infrastructure usually. We need to use internal VLDs, internal connection points. Okay, finally, we are exposing three connection points to the network service, and that's done in the connection point section. So that's it. At this point, I hope most of you have copied what is in here in slide 8. I mean, you already should have run the package create command, or the list create this magma directory. But well, you just please copy, run this command so that you see how OSM can create a VNFD template, and then take this faster path of copying the contents that we want on the folder that we just created through the tool. And I just went through what's the meaning of those contents. So once you have the VNF package, we need a network service package to be able to instantiate this VNF. So for that, we can again use the composer, which will let us build the network service, but in a limited way, because we won't be able to set all the parameters. Or the approach we're taking, again, is the CLI approach. So again, we have the package create command for that, but instead of setting VNF here, we are putting NS, and we just put a base directory and a name, and that's it. Because we don't need to set CPU or image or nothing. It's a more simple structure of the network service. A network service is the element that contains the VNFs that provides the actual service. For now, as I said at the beginning, the network service maps to the VNF one-to-one. In the future, tomorrow, we will add another VNF to our network service. So it will be a network service that has 2 network functions. The target we are trying to reach is here in this YAML file. So we are following the same approach. We are copying those contents of our network service to the magma directory that we just where we just built the network service. Okay. So let me do it and show you. Okay, so we are here, and we will run the package create command that refers to the network service. That is in slide 15. Okay, it created some things. Let's see. It created another directory which refers to the network service. And the only one that is populated is the YAML. So the YAML contains some basic structure, names, constituent VNFs. It replaces it with the name of the VNF it expects is the one we want, management VLD, and that's it. So network service just mainly refers to the VNFs that it wants to have to implement, and the VLDs that connect these VNFs, these external connection points. So we will follow the same approach of copying the resulting contents. And now our structure has changed a little bit. We have one VNF, and we are giving it a name which is different from just saying one. We are putting a name that says something more. We're referring to the VNF that we created in the previous example. We are putting 2 VLDs. No? One is the management VLD, which connects the 2 management connection points of the 2 VDUs. If you see here, these names are the ones we are using to expose the connection points in the VNFD. So the network service refers to the VNFD for getting the connection points that need to connect at any given VLD. And we have the SGI VLD, which, very important, refers to a existing interface in the Vim. If you see here is Vim network name SGI. And we are just connecting the access gateway SGI connection point in there. So we are starting to build what we have here. Show you. We're starting to build this in a network service. We define a network service and we define which connection points of the VNF that it contains connect to which VLD. Okay. So taking the same approach, at the end, the important parts, the constituent VNFs, which VNF ID will be part of the network service, and I'm putting it a name. And then which connection points of that VNF will connect to the management network, and which connection points will connect to the SGI network, which is the other network. So at the end, we are trying to build this here, right? Which is the blue block. It's connected to the management network up here and to the SGI network here. Both networks exist in our Vim. The management one is created, is indicated when we create the Vim, and the SGI network, it already exists in your tenant. You might have seen it. If you go to the network topology of your tenant, you will see that there is already an SGI network waiting for you there, and a management network waiting for you there. Okay, so we are connecting to those. Okay, finally, we are adding the Cloud-init files. What is Cloud-init? Well, for those of you that are new to Cloud-init, this is a way of automate some initial configuration of a VM or what we would call Day-0. Make the VM up and manageable, reachable. It can be used. Oh, you're seeing my presentation, right?
Yes.
Great. It can be used usually to define some language settings, define the host name, inject some keys, SSH keys, change the order of interfaces, adding some credentials, users, groups, modifying files, adding files, starting scripts, things like that. But it's very difficult to use it for real automation and operation. That's why we need something else for operation. And that's what we would call day one and day two, which is a completely different thing. Cloud-init is for basic initial configurations, just to get the machine started and reachable to be managed. So we have two Cloud-init files that came with what we copied. The Magma Access Gateway init file, which is located at this place here in your directory already. If you see here, it adds some routes and removes some other routes. Why we're doing this in this demo? Well, first of all, for learning purposes, we want to have example of many things. But second of all, this, for example, Magma EPC has a default route that goes through the management network by default, because the management network here in HCVim delivers a default route. But we want to have that default route for internet through the data plane interface, I mean, through the SGI. So for our particular case, what we are doing when we are launching this image, we are deleting the default route and replacing those default routes with just specific routes to the management blocks of HC network. One of these blocks belongs to your VPNs, for example, so that you are able to reach this machine from your laptops. We can see here that we can also provide parameterized information to the Cloud-init file. So for example, if you want to add a host route pointing to, in this case, the Orker orchestrator IP address, I mean the orchestrator IP address that we talked about, the orchestrator of Magma. We can provide it through a parameter at instantiation time, and OSM will automatically populate it here. So that's a very handy feature that we can use so that we can have parameterized Cloud-init files that change between different instantiation of different infrastructures. We are adding the default route towards the BIOS VNF, which is actually a router that is located at this address, and some other specific IP addresses that we want to reach through that path. Okay, so this is an example of what we can and are able to do at the Cloud-init that becomes is needed for our environments for this network service. And in the other SRS LTE init, which is used for the emulator, we are setting a password. That's another thing we can do. A fixed password, OSM 2020, for the default Ubuntu user of this image. And we are setting it not to expire, and you are setting SSH to accept password authentication, because by default the cloud images do not accept password authentication. And we are adding also some routes through the management network. It also has a default network through this management network, but we are removing it at a later stage with a Day-1 primitive. And tomorrow you will find out why we're doing this at a later stage. And in summary, it's because our automation engine, which is Juju, needs to download some packages from internet to deploy some things before being able to actually operate the machine. So we are giving it an internet access for a little while to the user emulator until it reaches what it needs, and then we operate it to reach internet actually through the other path, through the data plane path. And that's it. So we're just here exploring what we already got in this folder. So if you visit your terminal and you show one of these files, you will see it already populated. This is a format that is standard for the Cloud-init, and you can take the examples from the Cloud-init documentation, which is present in most Linux distributions. And this, for example, run command just runs command after the VM boots. And the other functions we are using are changing password and run more commands. Okay, so after you have explored the Cloud-init files, we will validate our package using the OSM network function package create command, and over our VNF, and the network service package create command over our network service folder. This single command will validate the package to see its contents are okay. It will build it. I mean, it will create a tar, a compressed image inside that folder, and will upload it in the same run to the OSM catalog. So I will share with you that. We'll share my whole screen just for you to see it completely. So first of all, we want to validate and build our VNF package. So I'm going to validate and build and create. This validated, the descriptor is valid. There's no chance to build, but it created a package, and you can see that it's created the tar.gz file, which we always use with OSM. It's already created there inside the same folder, and we use that tar to upload it automatically. So if I run the NF package list, most of you that already have experience with OSM or many of you may be new to these commands, which simplify things. And there it is, the VNF is already in our catalog. And then I will do the same for the network service. It's a small difference there, ns package create. I will do all of this, validate it, compressed, and upload it. So I'll run the command to see the catalog. There it is. So if I go now to the instance of OSM with my user, we'll see the same thing. Network service, VNF. Then you can edit as you like this. But if you edit here, of course, you won't be able to keep editing here. So personally, I recommend to always edit in here in these folders while building a VNF, and then just refresh or delete and recreate your packages. Otherwise, if you want to run quick tests, you can just update here and you don't need to refresh anything. Okay. So after you validated this, remember that we have a parameter in one of our Cloud-init files. I told you that we have this org IP address as a parameter. And if we don't provide that at instantiation time, then our network service won't be able to be launched. Okay. It's important that you provide it. How do you provide parameters? We just need to create a file. Well, there are two ways actually. You can put all this content in line with your ns create command, which is used for launching a network service. But it's easier if you create just a YAML file that contains your parameters. So I will do the same. In the same folder of Magma, I will put this params YAML or wherever you want to put it. And the important things here, sorry, there are spaces. It should not be spaces. Important things here is that you define the additional params for VNF attribute, then the member indexes you want to provide params to. In this case, I'm providing the member index of the VNF we created. And the additional params are the ones you are actually sending. So the important one is this one, org IP. It will be the IP address of the orchestrator we are going to launch tomorrow in the Kubernetes cluster. You put yours. This is very important because tomorrow everyone needs to have a unique IP address for launching the orchestrator, the Magma orchestrator. Otherwise, they will collide and one of them will not work. And then give your access gateway a name that you want, or keep these names, no problem. These are parameters that we will use later for tomorrow's automation session, and also the network name. So we should be ready for launching the network service. Let's try to launch it. Let me see if I have a beam. So in my case, it will be ns create with the ns name Magma Access Gateway 52. The name of the VNF of the network service we are launching, which is the same for all of us. The beam account that we're using, in my case, is etc OpenStack 52. And the config file params.yaml. If I run this, it will create a network service. It should instantiate something in OpenStack. If I I'll go to my own tenant. And in topology, I should see the VM being created. is active. And shortly I should see another one. There it is. So we have an virtual machine for our emulator and a virtual machine for our Magma Access Gateway. One is both are connected to management as expected. Both are connected to the internal IP VLD that we set with the addressing that we put. You can see there, 10 and 254. And only one of them is connected to SGI. So this is starting to look like what we are trying to build, which is actually this packet core here. We already have an interface, which is virtual for now. It's not the one that maps to physical interfaces yet. This is the S1 interface. We have the management in place, and we have the SGI in place. As soon as the virtual machines are ready, it will become active. And you will see that as well in network service instances section here in the dashboard. Right now, there should be a lot of traffic in the bin, so it's normal to have some delays. Okay, have both active, done, configured, running. Configured, well, it's just covering day 0 for now. But, well, we got our virtual machines. So what you can do, in addition to this, maybe, sorry, OSM VNF list, is do a OSM VNF list. You will see an IP address there, which is a management IP address of the VNF, which we mapped to our access gateway. You can see it's the same here. You can probably SSH to it. It's magma at magma. I mean, user magma, password magma. This is the packet core machine. And well, this is just in addition. You can, the main log we will be looking at after we have gone through the process of building all the services is the MME log. This is what this we will be looking at a lot since tomorrow. But if you want to give it a look, it should say how many eNodeBs are connected, how many users are connected, how many of them are active to send traffic. So this is our packet core. For now, it's not operational because it doesn't have a manager. Tomorrow we will be building its manager, which is the Magma Orcator.